Down there, life continues. The traffic is awful, stocks go on trading, and Star Trek is still showing.
Good day, grade 8 learners. Welcome to today's second natural sciences lesson in term 3. My name is Patricia Singo, and this lesson is proudly brought to you by the Gauteng Department of Education. In today's lesson, we're going to be learning under the knowledge area energy and change. The topic is energy transfer in electrical systems, and the subtopic, which is our main area of focus, is circuits and current electricity. All right, so now let's move on to today's lesson objectives. So these are the goals that we aim to achieve. So at the end of today's lesson, you should be able to define an electric circuit. Describe a circuit as a system for transferring electrical energy. Identify potential and kinetic energy in systems and describe energy transfer for each component making up an electric circuit and interpret an electric circuit diagram. And then the last objective is investigate the flow of current using a simple circuit board. All of this is from your CAPS document from page 47 to page 48. Let's move on to pre-knowledge. So this is what you've learned prior to today's lesson. It basically laid down the foundation of today's lesson. In the 5th grade, we learned about circuits and current electricity. And in the 6th grade, we were introduced to energy and change, a topic that we are adding more information on today. Okay, so let's look at today's baseline activity. I'm going to read out the questions and then give you time to answer the questions. And then please do send in your responses to our WhatsApp number, which is 079 578-2908. It should be appearing at the bottom of the screen. So let's see what we have in store for you guys for today's baseline activity. So the first question is define the following. So there are 3 terms you need to define. The first one, A, is static electricity. The second one, B, is electric charge. And the third one, C, is electric discharge. And then the second question reads, a sock falls from the washing line and clings to a wall. A, explain how this is possible, and then B, what makes the sock fall from the wall eventually. I'm going to give you 5 minutes to answer these questions, and then after 5 minutes, we will look at the solutions together. Welcome back, grade 8. I'm sure you had enough time to do all of the solutions. Don't forget to send in your answers to our WhatsApp number. If you want our WhatsApp number again, it is 079 578 2908. Okay, so now let's look at the solutions. So take out your pens and pencils and papers and see if you got any of this correct. So the first definition that was required is for static electricity. Static electricity, it is an electrical discharge caused by the buildup of electric charges on the surface of an insulator of electricity. An insulator of electricity, right, insulator. And then electric charge is the positive or negative property of a particle. Remember, we said particles are capable of being charged last week. And then electric discharge, it is the release of electric charge through a solid, liquid, or a gas. For example, lightning, if you remember from our lesson last week. And then the second question reads, a sock falls from the washing line and clings to a wall. So imagine a sock is on a washing line and then it falls from there and then it goes and clings onto a wall. So the first question is explain how this is possible. How is it possible that the sock doesn't fall to the ground, instead it clings to the wall? Or B, what makes the insulator fall from the wall eventually? So the first response is the friction between the sock and the wall causes it to be charged and stick to the wall, and what makes it fall eventually is electric discharge. Okay, so now let's look at the terms. What is an electric circuit? What is an electric circuit? It is a path through which electric charges move. It is a path through which electric charges move. And what is electrical current? It is the flow of electric charges in a closed circuit. It is the flow of electric charges in a closed circuit. What are conducting wires? This is a metal that allows current to flow through it. So if you have a metal that allows current through it, that it is possible, it is capable of conducting electricity. Okay. Now, what is a switch? What is a switch? It is a device used to control the flow of charge in a circuit. It is a device that is used to control the flow of charge in a circuit. So let's look at our second batch of terms. The first one is a cell. What is a cell? A cell is a chemical system that stores electrical potential energy, and then a battery, it's two or more cells. So if it's a singular, we call it a cell. If it's a battery, it's two or more cells forming a chemical system that stores electrical potential energy. And then what are resistors? This is a device that opposes the flow of current. It opposes the direction in which the current is flowing. And what is a filament? A filament is a very thin wire. You often see a filament inside a torch bulb. If you see that wire that is inside a torch bulb, that is what is called a filament. So now let's look at currents and circuits. Okay, now electric charges can jump over a gap between two objects. It can cause a spark or a shock. Remember last week when we were learning about friction and static electricity, right? And then a path can be created for electric charges to move from one object to another. And this path is called a circuit. This path is called a circuit. Remember when we were learning in our lesson last week, when we were learning about friction and static electricity, how non-conductors of electricity are capable of going through friction and then becoming static. Now, we can create a path that allows for the flow of electric charges. Remember, we said electrons are the only particles, they're the only subatomic particles that are either lost or gained. We can create a path for their movement from one object to another object, and that path is called a circuit. Let's look at this diagram here. We have got a cell, so there can be a path. So this red line there, that is the path in which the charges are moving. So they are moving from here through there to there. Okay, so this is a circuit. So that is a circuit. Okay, so a simple circuit, the most basic circuit, has the following items. It has a source of energy, and that source of energy is a cell. It has conducting wires for electric charges to move. And remember, when we're defining what conducting wires are, we said they are metals or materials that allow current to flow through them. So a simple circuit has a cell and conducting wires. What else is there? There is a bulb. It could be a big one or just a small torch bulb. And then we have the flow of electric charge in a circuit, which is called an electric current. So these are the three components: component 1, component 2, and component 3. So that makes up a very simple circuit. You can actually make this at the lab at school. It's very, very simple to make. Let's look at a picture here. So this is our cell. In case you didn't know what the cell is, that is our cell. And then these two, 1 and 2, those are our conducting wires. And then this is then our bulb. That is our bulb. So this is basically a very, very simple circuit. That is a simple circuit. Okay. Now a circuit is a system. It is a system that transfers electrical energy. So when we talk of the word transfer, which means something is moving from a certain point, something is moving from point A and moving on to point B. There is movement, something is moving. So now the cell is the energy source. If you remember from your 7th grade, we learned about potential energy. So a cell is a source of energy. So chemical energy from the cell is transferred to electrical energy. If you remember from the 7th grade, we learned about the different types of potential energy. We had gravitational potential energy, we had chemical potential energy, and we had another one, elastic potential energy. So a cell is a nice example for chemical energy. So the chemical energy within the cell is transferred to electrical energy. It is transferred to electrical energy. Now, let's look at this diagram here. We are talking about this item over here. That's the item that we're talking about. So that is our source of energy. This is where we're getting the energy from. It is the source of energy. We have chemical energy within the cell that is being transferred into electrical energy. All right. So now electrical energy can be converted to the following: light and heat energy in the bulb. If you touch a bulb, if it's safe enough to touch a torch bulb, you will see that it feels a bit warm. So that is the heat energy. And if you just look at the torch bulb, when you switch on a torch, you will see light. So electrical energy is capable of being converted to these two, which is light and heat energy. So now the cell, conducting wires, and the bulbs, they work together in the system that is transferring energy. Remember, when we're transferring something, it is being moved from point A to B to C to another point. So these three work together to create a system, and the system is transferring energy. So what happens really in a circuit? So the first thing that happens is an energy source provides chemical energy. Right, so the chemical energy, remember this electrical energy that we're talking about. Okay, so it is provided by the energy source. We said the energy source is the cell. It is provided by the cell, which is the energy source. So now, after we've provided the chemical energy to the charges, and then it moves on to the conducting wires. So we now know our starting point. The starting point is the cell. Then from the cell, we move on to the conducting wires. So this is our energy source. So our energy source provides chemical energy, now which is then transferred to our conducting wire. So this is our point A and this is our point B. So we now know where we started, and now we know our second point of transference. Now, so charges use kinetic energy to move electric current. Remember, kinetic energy is the energy of movement. Okay, it is the energy of movement. So now energy is transferred again to the device. It's either heat, light, sound, or another type of energy, depending on what you've connected. If you've connected your heater at home, you can get heat from the heater, and you get light. As you see, the bars are glowing. The bars are glowing. If you've connected a radio, you get sound from it. If you're watching the television, you get light. Remember, it's light. And then you can also get light from a bulb as well. So there's different kinds of energy that you can get. It's up to you to figure out which one it is. Okay. Now, so all electric appliances function because the circuit is complete. They function because the circuit is complete when connected to either a power source such as a cell, battery, or electric mains. Here I've got a battery, and then here I'm sure you've seen these around your homes, you've seen them at schools, you've seen them in different kinds of buildings. You've seen these before, you've seen them in different kinds of buildings. So that is a mains or a power outlet. It is a source. It is a source, it's a power source. So having that particular item, whether it's your TV, it's your radio, it's your heater connected to the mains, it completes the circuit. It completes the circuit. That is why your object or your appliance is able to function, because the circuit is complete. If you unplug it from the mains, the circuit is now incomplete. So now that the circuit will be incomplete, then your appliance won't be able to function or do what it wants to do, whether it's a kettle, you're trying to boil water, or it's a blender, you're trying to blend something. So the circuit has to be complete for an appliance to work. So now we're figuring out what makes up a circuit and what is a complete circuit. Okay, so an open circuit is one in which electric current cannot flow because it is open and because the pathway is not complete. Remember, we have been saying for your kettle to work, you need to plug it onto the mains, switch the switch on, switch the kettle on, and then it works because it is a complete circuit. For your torch to work, that handheld torch, for it to work, the circuit has to be complete for it to be able to function. If it is open, or if your TV is not plugged to the main, then that is an open circuit. It is an open circuit, so current cannot flow, then the pathway is not complete. Then the TV is not going to work. However, a closed circuit is one in which electric current is allowed to flow. It is allowed to flow. And then a closed circuit is needed to make a device work, such as a torch bulb to light up. Your refrigerator to work, you need to plug it to the mains. The TV to switch on, you need to plug it to the mains. The torch to switch on and the torch bulb to glow, you need to have a complete circuit, a closed circuit. So you need to remember, open circuit, electric current cannot flow because it is not complete, because the pathway is not complete. A closed circuit, electric current is allowed to flow because it is a complete circuit. It is a complete circuit. So open circuit, current cannot flow. Closed circuit, current can flow. Okay, now let's look at this diagram here. I want you to focus on this area, this particular area there. When this switch flips open, the bulb switches off. There is no flow of electric current because the circuit is not complete. There is a gap and the current is not able to move from this point to that point. However, when that switch is closed, when the circuit is closed and that gap is closed, then we have the bulb switching on. Just give yourself some time. Just look at when the bulb switches off, it's because there is an open circuit. When the bulb switches on, it means the circuit is now closed and current is able to flow. Those arrows are representing the flow of electric current. Those arrows are representing the flow of electric current. So now we're going to move on to our first activity. We've done the baseline activity, so this activity is based on what we've just learned today. So the first question is label the parts of the circuit numbered 1 to 5 below. So you look at that diagram, you label each of the following parts: 1, 2, 3, 4, and 5. And then number 2 reads, in which part of the circuit is the energy stored? You tell us. And then number 3, what is the function of part 1? You tell us what it is. I'm going to give you 5 minutes to answer these questions, and then after 5 minutes we will do the solutions together. Welcome back, grade 8. I hope you are sending in your responses. If you didn't catch our number, it's 079 578 2908. You can also send questions if you have any questions. If there is a concept that you didn't understand, please feel free to send in your questions and then we will answer them at the end of the lesson. So now let's look at today's responses. Label the parts of the circuit numbered 1 to 5 below. There's number 1, 2, 3, 4, and 5. So what is number 1? Number 1 is the bulb. If you wrote bulb, just give yourself a mark. And then number 2, those are conducting wires. If you wrote conducting wires, give yourself a mark. Number 3 is a cell. Number 3 is a cell. Give yourself a mark for that one. Number 4 is the positive terminal of the cell. So that is what that plus means. So next time, if you see a cell or batteries at home and you see a plus and a minus, just know or tell somebody that I know what this is. This is a positive terminal. And then number 5 is a negative terminal. In which part of the circuit is energy stored? So where here is the energy stored? The energy is stored in number 3. What's number 3? It is stored in the cell. It is stored in the cell. What is the function of part 1? What is part 1, by the way? We check in our answers, the bulb. So what purpose does the bulb serve? What is the function of the bulb? Is to provide light. It provides light and acts as a resistor in the circuit. So it's going to glow once the circuit is closed. Once the circuit is complete, it is going to glow. I'm just going to give you a minute to copy down the answers, and then after a minute, we'll continue with our lesson. Welcome back. Now let's move on to the next slide. We're still doing circuits and current electricity. So electrical energy is stored in a cell, right? And the more cells are connected, the greater the amount of electrical energy that can be stored. So do you understand? So we have electrical energy in a cell. But if we have more than one, we have more electrical energy. So now the components are connected from the terminal. So remember we said we have a positive terminal, we have a negative terminal of the source of energy, which is the cell. And then along conducting wires, which are usually copper, we usually use copper wires. That's why sometimes when there's maybe an open cable, you can see red like or copper colored rather, or red like wires popping out of that wire. Those are copper wires. They are the usual go-to for conducting wires. So now along the conducting wires and through the device, which is the bulb. It could be a bulb, it could be a radio, it could be anything, which is the device, and then back to the source of energy, completing the pathway. So remember, the pathway always has to be complete for that radio to start chiming and singing, and for that torch bulb to start glowing. It has to be complete. Now, so a component that opens and closes the circuit. Remember that diagram I showed you that had the flipping and closing, open and closing. That is called a switch. It's called a switch. And a torch, if you've seen a torch before, it has a switch that opens the circuit so that there's no flow of charge. And it also closes the circuit so that there is a flow of charge. So in the case of the torch bulb that doesn't give light, it means, so in the case where the torch bulb doesn't give light, it means you have an incomplete circuit. It means you have an incomplete circuit. So when the switch is on, there is flow of electric charge and the torch bulb gives off light. There's our torch. I just want to show you this part here. That part there. So that is where we have our switch. So switching it on and off either completes the circuit or renders the circuit incomplete. So that is the torch. So now we've reached the part in our lesson where we're going to do an experiment. So what are we going to do? We're going to build a simple circuit. So we're just going to take a short break so that we go to the lab, and when we come back, we will begin our experiment. Welcome back, grade 8 learners. So now we're going to do our experiment. So let's find out what the aim of the experiment is. The aim of the experiment is to make a simple circuit. So today we're going to be making a simple circuit. So these are the materials or apparatus that we're going to use today. We need 3 cells, 2 conducting wires, a torch bulb, and cell holders. So these are the steps that we're going to need to follow to build our simple circuit. Step number 1, you need to connect the cells to the cell holders. Step number 2, take one conducting wire and connect it to one terminal. Number 3, connect the second conducting wire to the second terminal, and then connect the conducting wires to the end of the bulb holder. Alright, and then you write the observations of what happens to the bulb. So now I'm going to physically show you the materials that we're going to use. So we said we need 3 cells. So these are the 3 cells that we're going to need. Then we said we're going to use a torch bulb. So here is a torch bulb. It's in our torch bulb holder. Then we need 2 conducting wires. These are the 2 conducting wires that we're going to use, a red and a black one. And then our bulb holders are already secured onto this board. We call this board a circuit board. So the first step is to connect the cells to the cell holders. Now, so this is the positive end of the cell. As you can see, this plus sign, and here this is the negative end. So the positive end of the cell is supposed to face the left hand side, as you can see on the bulb holders, there. So I'm going to connect the cells. That's cell number 1, cell number 2, cell number 3. Next, we're going to put the conducting wire. So the red wire is going to be connected to the positive end. So the positive end, that's where we're going to connect the red wire. So we're connecting just one piece of it. We're going to leave the other piece hanging for now. And then the black wire, the black conducting wire, we're going to connect it to the negative end. And then this is our bulb. We're going to place our bulb here. Now, next, we're going to connect the negative end of the cell. We're going to connect the negative end of the cell. So now, to complete the circuit, we need to connect the second conducting wire to the end of the bulb, and then watch what happens. Alright, did you see that? So when I remove this wire, do you see what happens? So this is a complete circuit. When it is like this is a complete circuit. When everything is connected, the cells, the conducting wire, and the bulb. Now it becomes incomplete when I take away one of the conducting wires. It becomes incomplete. Right, let me do that one more time. There we go. See what happens? Now write your observations. So now let's discuss our observations. What did you observe today, and what do you conclude from what you observed? We observed this, but what exactly is it? We had cells or batteries. We had an electric lamp glowing. Now, this is because there is current flowing. So how can we put this into words? We can put this into words as follows. What we observed was the bulb switches on. What do we mean by switches on? It glowed. Remember when it glowed, that bright yellow color? It glowed. And then what can we conclude from this? We can conclude that when the circuit is complete, the current will flow and the bulb will switch on. When the circuit was complete, the bulb switched on. But when we removed one of the conducting wires, the bulb would switch off. So the circuit is incomplete when one of the conducting wires was not connected, but the circuit was complete when all the conductors were connected. All right, now let's go back to our lesson and see you soon.
Excellent. Excellence is a habit. Excellence is a quality you have, a quality I have. It's a quality we have when we honor what is true to us. Yes, we are gifted differently. uNkulunkulu akasinanga ngokufana. Excellence is striving for your best. Whenever you have a particular project, test, homework, uzibuze, ask yourself, is this my best? Can I put in more effort? Excellence is striving to be in the top 1% of the area in which you are gifted. And so I challenge you, in every single thing that you do, in every single area that you're gifted in, whether it's sports, it's academic, ucula, whatever that gift is, strive for excellence.
Hello grade 8 learners, welcome back. I'm sure you enjoyed our practical, our experiment. So now I've got an activity for you guys to do. So this is the second activity of today's lesson. I'm going to read out the questions and then give you time to write down the solutions. Solutions are coming in. Thank you so much for sending in your solutions. I see you learners from Soshangube, you're sending in your solutions. Now, let's read the question. Identify the systems that transfer electrical energy from the below figures and answer the following questions. So we've got a horse, a man riding a bicycle, and we have a torch. So the first question is identify a picture that represents a system that transfers electrical energy. The second question is describe the energy changes that occur in two other photos, and then explain why the other pictures do not represent systems that transfer electrical energy. I'm going to give you 5 minutes to answer these questions, and then after 5 minutes, we'll look at the solutions together. Keep on sending in those responses. See you after 5 minutes. Welcome back, grade 8 learners. I just want to say yay to the learners from Social Ngube Technical SOS, the School of Specialization. Thank you for sending in your responses, and I can safely say they got all the answers correct. So now let's look at the answers from activity 2. We're supposed to identify a picture that represents a system that transfers electrical energy. We've got a horse, a man on a bicycle, and a torch. So which of these three represents a system that transfers which kind of energy? Electrical energy. So which one is it? It is the torch. It is the torch. Why am I saying it is the torch? Because it has a battery, it has conducting wires, a switch, and a bulb that forms a circuit. And the battery is the torch's power source. Remember, the battery or the cell has chemical potential energy, which is transferred or converted to electrical energy. So it is the torch. If you wrote torch, please do send in your answers. If you have questions, if there's something that you do not understand, please do send in your questions to the WhatsApp number at the bottom of the screen. Let's look at question number 2. Describe the energy changes that occur in the two other photos. So we've got the man on the bicycle and the horse. The man on the bicycle and the horse. The man that is riding the bicycle represents mechanical system, a mechanical system that transfers a man's potential energy in his feet to kinetic energy, pushing the pedals of the bicycle. It is pushing the pedals of the bicycle. What about the horse? The horse is eating grass. It's eating grass, as you can see there. The horse is eating grass. It represents another biological system that transfers chemical potential energy from the grass to the horse. From the grass to the horse. What's question number 3? Explain why the other pictures do not represent systems that transfer electrical energy. Why doesn't the horse and the man on the bicycle represent a system that transfers electrical energy? So neither the man on the bicycle nor the horse have an electrical power source. The torch has a battery, it has a cell, which is our electrical power source. But the man and the horse do not have an electrical power source. So now let's talk about the responses. So we have been getting responses from the Social Ngube Technical School of Specialization. They got all their answers correct for all the activity. Thank you for sending in your responses. Please do keep on sending them. So now I've got your homework activity. I'm going to read out the questions and then give you time to copy down the questions. Please send in those questions after the lesson is done. This is our homework. We will respond to your answers. The first one is draw the circuit diagram using the following components. We have a cell, a bulb, and a conducting wire. So draw a circuit diagram. Remember from our practical activity, so you draw something similar to that. And then explain how a switch controls the flow of charge in a circuit. So I'm going to give you 2 minutes to copy down the questions, and then we will summarize our lesson. Welcome back, grade 8 learners. Welcome back. I'm sure you've copied down all of the homework questions. Now, let us summarize our lesson. What did we learn today? We learned that a circuit is a system for transferring electrical energy. A circuit is also a pathway through which electric charges move. We also learned that a closed circuit is needed to make an electric device work. Every day we come across different electric devices. We've got a torch, there's cell phones, television sets, a radio, the stove, the refrigerator. There are different electric appliances that we use in our day-to-day life. But for them to be able to function, the circuit has to be closed. So for the circuit to be closed, you need to plug it onto the mains and switch on the switch there. Then the device starts to work. If you've got a much simpler device like a torch, a handheld torch, you need to put the batteries inside the torch and then switch it on by pressing the switch. Then you have your torch on. So it has to be closed. The circuit has to be closed to make the device to work. We also learned that electrical circuits can be represented by circuit diagrams. I've been showing you circuit diagrams throughout the lesson. When we were doing our experiment, our practical experiment, after we connected the components of the circuit, I showed you a diagram. That is how we represent a simple circuit. So that is a circuit diagram. So there you are supposed to know which symbol represents a battery, which symbol represents conducting wires, and which symbol represents the bulb. We will also do more of that in our lesson next week. Okay, so now what is a complete circuit? A complete circuit means closed circuit, which means the switch is on. It means the switch is on, so that is our complete circuit. And then an incomplete circuit means it is an open circuit, which means the switch is off. So when the switch is off, this circuit is open, it is not complete. So the electrical current or electrical charges are not able to flow right around the entire system. They are not able to flow right around the entire system. I've got diagrams to represent our circuit. So we've got diagram A. I'm going to call this diagram A, and I'm going to call this one diagram B. Diagram A has the lamp that is glowing. It's glowing, it's shining, it's bright. Why? Because the circuit is complete. There are no gaps here. You see, there are no gaps, and our switch is on, so it is closed there, and our circuit is complete. Then diagram B, the light is not glowing. The light is not glowing. There's a gap over here, which means our switch is off and our circuit is incomplete. We can also represent A and B in this manner. So when you're drawing in your notebook, you can represent it in this manner. So this is how we represent a battery. We represent it by lines. So there's one line that's longer than the other. So the longer line is the positive end of the battery, and the shorter line is the negative end. If you're seeing one long line and a short line and another long line and a short line, it means we have two cells which make up a battery. And then we have this over here. This represents our electric lamp. It could be a torch lamp or any other lamp. So this circuit is complete because there are no gaps. Can you see? There are no gaps over here. There are no gaps at all. And then over here, this one, the bulb is not glowing. The bulb is not glowing, it's not shining because the circuit is incomplete. Why? There is a gap here. It is incomplete. So current is unable to flow from point A to point B, from this point to that point, because there's a gap between the conducting wires. There's a gap. So the electric current is unable to flow completely. So we're saying this one is incomplete. It is a nice representation of B. It is a nice representation of B. All right, grade 8. Thank you so much for joining me in this lesson. I hope you thoroughly enjoyed it. Until next time, bye-bye.